How do you actually find the hidden patterns in your data? It's a huge question, because often the groups we think we see are really just the tip of the iceberg. Today, we're going to explore what happens when we let go of our assumptions and let the data itself reveal the real, much more interesting story that's hiding underneath.
Okay, so let's start with an example. When you think about the ethnic groups of Nigeria, what number comes to mind? For most people, it's 3. The big ones, the Igbo, the Yoruba, and the Hausa. It's a nice, simple, easy-to-remember number.
But here's the thing. The reality is way, way more complex. In Nigeria, there are actually over 250 distinct ethnic groups. Can you imagine? Forcing all of that incredible diversity into just 3 little boxes? You lose so much detail. It creates a completely misleading picture. And you know what? This isn't just a problem in demographics. It's a huge challenge we face every single time we work with data.
And that really gets to the heart of the problem here. When we force complex data into a few boxes that we just came up with based on our gut feeling, we almost always get a messy, inaccurate picture. It's kind of like trying to sort all clothes into just small, medium, or large. It just doesn't work for most people.
The thing is, when our groups are way too broad, they just stop being useful. Lumping a bunch of very different tribes into a single category like Yoruba, it pretty much erases what makes each of them unique. And this isn't just about being inaccurate. It leads to a really poor understanding of the world, and that leads to bad decisions.
So, how do we fix this? If guessing is bad, what's the alternative? How can we mathematically measure how messy or, poorly defined our groups are? We need some kind of score, right? A way to tell us if we're even on the right track.
Well, that's where this really cool concept called inertia comes in. Just think of it as a score for how tight and cohesive a group is. A low inertia score means all the data points are huddled together, super close to their center. But a high score, that means they're scattered all over the place. It's basically our mathematical yardstick for messiness.
So the goal becomes really simple. High inertia is bad. It means our group is a mess, the data points are spread out, and it's not a good representation of anything. What we want is low inertia. That means everything is tightly packed, creating a clear, accurate, and truly representative group. The whole game is to get that messiness score as low as possible.
Okay, so if the goal is to get the lowest inertia score, how do we find the perfect number of groups to actually get there? We can't just guess again, right? Well, instead, we use this really clever technique called the elbow method that actually lets the data itself tell us the answer.
The process is super systematic. First, we just let the model test a bunch of possibilities. It creates one group, then 2, then 3, and so on. And for each one of those tests, it calculates that inertia score. Then you just plot all those results on a chart, and you look for a very specific shape. It looks like an elbow, and it tells us the exact point where adding more groups just stops being helpful.
And this quote just nails the whole idea, doesn't it? This is a fundamental shift in how we think. Instead of us imposing our assumptions on the data, we let the model dig in, understand the data, and then tell us what the best number of groups should be. It's a move from pure guesswork to actual data-driven discovery.
So let's look at the actual numbers. Here, k is just the number of groups we're testing. With just one group, so k equals 1, the inertia is massive, 55,000, super messy. As we add more groups, you can see the score drops fast. But watch what happens after 7 groups. The improvement you get from adding an 8th group or a 9th, it becomes tiny. The line is really starting to flatten out.
And that flattening point, that's exactly what we call the elbow. It's the sweet spot. It's the data screaming at us saying, hey, adding more groups beyond this point isn't really making our clusters any tighter or more meaningful. It is the classic point of diminishing returns.
And there it is. The model found the answer for us. The optimal number of groups isn't 3, like our first guess back with the Nigeria example, it's 7. We've let the data, not our own intuition, guide us to a much, much more accurate way of seeing our information.
So this method is all cool in theory, right? But what can you actually do with it? Well, let's apply this to a real-world loan data set and see what kind of hidden customer groups we can uncover. So after running our model with 7 clusters, we can now look at the results. And right away, boom, something just jumps off the page. We can see these clear differences between the groups. But look at cluster 4. On average, the customers in this group are asking for loans around $7,500. That's way more than the others.
I mean, think about what just happened here. We took this one big, messy pool of customers and turned it into 7 distinct, understandable segments. We instantly found a potentially high-value group. That's cluster 4. And we can even spot the outliers. This is the kind of insight that's totally impossible to find when you're not letting the data speak for itself.
Okay, finding these groups is awesome, but that's just step one. The real power, the real magic, comes from the questions this new understanding lets us ask. This is where data actually turns into a strategy.
So we know who our high-value customers are. The first logical question is, how do we talk to them? What kind of marketing is actually going to resonate with people who are looking for larger loans? We can now be so much more specific and way more effective.
But of course, a bigger loan request also means bigger risk, right? So the next critical question has to be, do these customers actually pay their loans back? We have to dive into their credit history to make sure we're balancing this amazing new opportunity with the potential risk.
And then finally, we can start to get really creative. Could we build a brand new product? Maybe design a special offer, like a lower interest rate for loans over a certain amount, specifically to attract more customers just like the ones in Cluster 4? This is exactly how data-driven insights lead straight to business innovation. So by just moving beyond our own assumptions and letting a pretty simple method guide us, we uncovered a much richer, more actionable picture of our customers. And that brings us to the final thought I want to leave you with. What valuable, hidden groups are just waiting to be discovered in your data?